Dear students, today I will discuss properties of chi-square distribution. The properties of chi-square distributions are given below. 1. If n is equal to 1, the chi-square distribution has the normal form, and simplify the positive half of the normal curve. Second property, if n greater than 1, the curve is unimodal type skew curve with x-axis as the tangent at the origin. It is that the curve is skewed to the right and the coefficient of the skewness is positive. Third, as n tends to infinity, chi-square distribution tends to normal form. Fourth, when chi-square is equal to xi, therefore d of xi is equal to 1 by 2 raised to n by 2, gamma of n by 2, e raised to minus xi raised to n by 2 minus 1 d xi. Therefore, the characteristic function psi of xi is equal to 1 minus 2 it bracket raised to minus n by 2. Therefore, the moment about the mean is given by, that is, mu1 is equal to n, mu2 is equal to n, or sigma square is equal to n, mu3 is equal to 8n, and mu4 is equal to 48n plus 2n square. Now, using the moments of chi-square distribution, the moments of chi-square distribution are obtained by using MGF and CGF. Now, first using the MGF of chi-square distribution, let us suppose that x follows chi-square with n degrees of freedom. Then the PDF of chi-square distribution is given by, that is, f of x is equal to 1 by 2 raised to n by 2, gamma of n by 2, e raised to minus x by 2, x raised to n by 2 minus 1 dx. Here chi-square is equal to x. Therefore, MGF is given by mxt is equal to expectation of e raised to tx, that is equal to integration 0 to infinity e raised to tx f of x dx. Therefore, f of x is equal to integration of 0 to infinity e raised to tx. F of x is nothing but PDF of chi-square distribution, that is 1 by 2 raised to n by 2, gamma of n by 2, e raised to minus x by 2, x raised to n by 2 minus 1 dx. That is equal to, take 1 by 2 raised to n by 2, gamma of n by 2 outside the integration. Integration of 0 to infinity e raised to tx into e raised to minus x by 2, that is e raised to tx minus x by 2 into x raised to n by 2 minus 1 dx. That equal to 1 by 2 raised to n by 2, gamma of n by 2, integration of 0 to infinity e raised to minus of minus 1 minus 2t divided by 2 into bracket x, here x taking common, into x raised to n by 2 minus 1 into dx. That equal to 1 upon 2 raised to n by 2 gamma of n by 2 into, that is integration of 0 to infinity e raised to minus of 1 minus 2t by 2 into x, x raised to n by 2 minus 1 dx is nothing but gamma of n by 2 divided by 1 minus 2t upon 2 raised to n by 2. Using these relations, integration 0 to infinity e raised to minus x into x raised to n minus 1 dx is nothing but root n upon a raised to n. That equal to 1 by 2 raised to n by 2. Here gamma of n by 2, gamma of n by 2 cancelled. That is 2 raised to n by 2 divided by 1 minus 2t bracket raised to n by 2. Therefore, MGF of t or mxt of t is equal to 1 minus 2t raised to minus n by 2, which is the MGF of chi-square distribution with n degrees of freedom. Next, using CGF of chi-square distribution. The notation is the CGF of chi-square distribution of kx of t is equal to log of mxt. That is equal to log, already you know, mxt 1 minus 2t raised to minus n by 2, that equal to, take log inside, minus n by 2 into log 1 minus 2t, that equal to n by 2, simplification of 1 minus 2t using 1 minus x formula, into bracket 2t plus n 2t raised to 2 divided by 2 plus 2t raised to 3 divided by 3 plus 2t raised to 4 divided by 4 plus and so on. Now using k1 of t is equal to coefficient of t in kx of t, that equal to, take n by 2 above steps, n by 2 into 2, that is equal to n. Similarly, k2 of t is equal to coefficient of t square by 2 in kx of t, that equal to n by 2, take our inside the bracket, n by 2 into 2 square upon 2 square, that is equal to n into 4 by 2, that is equal to 2n. Next, k3 of t is equal to coefficient of t cube divided by 3 in kx of t. Similarly, that equal to n by 2 into 2 raised to 3, 3 into 2 into 1 by 3, that is simplification a10. k4 of t is equal to coefficient of t raised to 4 divided by 4 in kx of t, that equal to n by 2 into 2 raised to 4, 4 into 3 into 2 into 1 divided by 4, that simplification is 48n. In general, kx of t is equal to coefficient of t raised to r divided by r factorial in kx of t, that is equal to n into 2 raised to r minus 1 into r minus 1 factorial. Now, we obtain moment by using CGF, that is mean is equal to k1, that is equal to n, variance, that is equal to k2, that is equal to 2n, mu3 is equal to k3 plus a10. Already you know k3 is 3n, k3 is equal to k3 plus k3 is equal to 8n, k4 is equal to k4 plus 3 into k2 square, k4 is 48n plus 3 into k2 square, k2 is known, that is 2n, that bracket square, that is equal to 48n plus 2n square. Similarly, using beta 1 is equal to mu3 squared by 2, that is equal to 8n bracket squared by 2n raised to 3. Similarly, b2 is equal to mu4 upon mu2 square, 48n divided by 2n bracket square, that is equal to 48 divided by 4n, that is 12 by n, which is the required moments of chi-square distribution. Thank you.